Good evening, everyone. Am I audible? Could you please confirm? Hello? Am I audible? Thank you. So, we have almost completed the 2 weeks of the course. Uh, Thank you. We have almost completed the 2 week of the course, means two-thirds of the course is done. Now, one more month is left. 4 more weeks. And now we have completed almost all the water treatment, primary treatment part, as well as secondary treatment part. So basic difference between primary and secondary treatment is, in primary treatment we talk about inorganics, and there we are using gravitational methods as well as physicochemical methods for the treatment, mostly physical methods. Now when we talk about secondary treatment, we talk about the biological means the use of microorganisms for the treatment of wastewater. Now, in both the treatments mechanism, physical as well as biological, means unit processes and unit operations. I hope you remember the difference between them. There will be sludge, means when in a wastewater you must have seen in drains, water below the water we have sludge. So when we treat all these things, all these wastewater inside our sewage treatment plant, so the influent is divided into two phases. Supernatant means the uh, phase above will be watery phase and the below will be sludge. So till now we were just talking about the water, like how this water we are treating, this wastewater means the water phase which we are treating, how we were doing the primary treatment, how we were doing the secondary treatment. Now we will talk about the below phase, means the sludge. In every stage of treatment, we will get some sludge. Sludge means the solid biomass will get. In primary sedimentation tank, the sludge and the grit chamber, as well as from the beginning, screenings. Step 1 was screening. I hope you remember this thing. So what we were getting was the inorganic sludge as well as big particles like paper, log, all those things we were getting, plastic packets. So these are inert particles. These, what we do, we most of the time we just directly do not treat them. We just directly take them to the our landfills. Coming to the second stage means primary sedimentation tank. After that, whatever particles will get will be big organic particles. These are quite heavy. These will settle down. So we have one set of sludge which are from the primary sedimentation tank. Coming towards secondary treatments means biological or the treatments based on microorganisms, we will get some sludge. Here in this stage, our sludge is mostly biomass. Biomass means mostly the bodies of microorganisms. Because why we get more microorganisms? Because there will be food. These wastewater, the soluble organics will be food for microorganisms. And what we do mostly in aerobic treatment, in secondary treatment, we do aerobic treatment. So as you know, in aerobic treatment, more biomass are produced than anaerobic treatment. That is why the sludge consists mostly of biomass. That is, we get some sludge from here. Now coming towards tertiary treatment, depending upon the process, like if we are doing any chemical precipitation, we will get different types of sludge. If we are doing just some filtration, we will get different types of sludge. So all these different types of sludge from secondary, primary to tertiary requires different types of treatment. We cannot just generalize the treatment. So this week was all about the sludge treatment. But here we have basically talked about the primary and secondary sludge only, less of tertiary. So I'll share my screen. I hope you have gone through the lectures. I'll share my screen and we'll solve some questions. In case of any doubt, you can ask me in between or you can put in the chat box. For answering the questions, I have made one poll of different questions. So I'll launch poll time to time so that you can see and answer there. And if you couldn't find the poll, you can answer in the chat box as well. I hope you got it. I'll share my screen now. Okay, so this is week 8 sample problem. I'll start the polls. So this is the poll for question number 1. Now we'll see the questions. If you have gone through the lecture, these questions will be very easy for you. So it will be better before coming to any live class, you should go through the lectures. But in case of any doubt, we'll solve it together. So this is the question number 1. Arrange the steps of sludge handling in sequence: drying, thickening, hygienization, dewatering, and stabilization. So what will be the steps? These are the basic steps mostly we use for primary and secondary treated sludge. So what are these steps? These steps are really important. We do not want to skip any. The main purpose of doing these things is first of all volume reduction, because we don't want excess sludge. We want the volume to be reduced so that transportation cost can be reduced as well as handling in easy. Second thing, we don't want any pathogens to be there in the sludge, because we humans are handling that sludge, right? So these two things are very important: volume reduction and no pathogens, no smell we want. It should be clean, hygienic. That's all we require, so that we can use that sludge further, or we can just dump it somewhere. So we don't want any environmental loss. So what can be the answer? A, B, C or D? You can answer in the chat box as well as polls, whatever suits you. Yeah, I'm getting the answer. Okay, we'll see the answer. So the answer is 3. C. First we will go for thickening. Thickening, why we do? We just try to reduce the volume. Important point. Then we go for stabilization. What do we do in stabilization? In thickening, the volume reduction is like uh, it's very less. So that we can just handle it. Stabilization, what do? We try to kill the pathogens as well as odor, and if there are any organic particle which may cause problem in the further process, which may degrade, causes a smell, we try to remove all those things. Dewatering, after dewatering, sludge is like okay, it's not watery. In thickening stage, sludge is still flowy, it may flow, but after dewatering, it's not flowy, it won't flow. Then hygienization, it's also kind of pathogen removal process. Then drying we can do anywhere. In some places, after, if all these processes are done quite nicely in a well stabilized manner, then you know what we do for drying? We just put the sludge on the sand bed. The water will percolate below if there is any water, and the rest of the things we use as cake. And in some places, uh, what do? We can auction these cakes, sludge cakes, to farmers. Farmer will take them to their farms, because now it's very stabilized. There is no odor, there is nothing, but lots of nutrients are there. So they may use it for as a compost or as well as fertilizer for their farms after the drying stage. We'll see next question. This is question number 2, and these are the polls for question number 2. Which of the following can be viewed as a constraint of fuel-based sludge use, such as incineration and gasification? What do we do in incineration? We just burn it. Whatever is there, we just burn it. Second is gasification. So what are the constant of fuel-based sludge? Why don't we go for these things? Because incineration, if we incinerate it or if we gasify it, volume reduction will be very quick. Almost 90% of the volume will go. So why don't we use it?
All the above.
Yeah, correct. Yeah, all of the above will be correct answer. It will be D. Okay, I'll make the correction while I'll upload it. Expensive, yes, this will be expensive because lots of energy will be used. Energy in the form of heat will be used. As generation and disposal is the problem. Yeah, that will be there. And requirement of skilled operator. We cannot allow it these things to be handled by anyone. We require some skills. Okay. And skill also involves the use of various safety equipments. So answer will be D, all of the above. This is next question, and these are the polls for question number 3. Which of the following is a major challenge in sludge management? Reducing the water content, managing risk causing organisms and chemicals, recovery of nutrients, mainly nitrogen and phosphorus, or all of the above. So, major challenge you want to say. So, the answer is D. All these things we want. Reducing the water content, as I already told you, it reduces the transportation cost as well as handling in the further process. And this we don't want because we are handling it. We don't want any risk causing organisms, means pathogens we don't want, and we don't want any harmful chemicals. As well as recovery of nutrients means when we will use these things, these dried cakes in our fields, what we want, nutrients will be extracted from that so that it can be used in fields. So that is what we call recovery of nutrients. We are using sludge as a fertilizer. So we are using the nutrients in the sludge. Okay. This is the question number 4, and these are the polls for question number 4. Anaerobic sludge digestion is the process where anaerobic. I hope you remember what I told you about anaerobic in the previous lectures as well as live classes. Anaerobic sludge digestion is the process where the digestion takes place only in the mesophilic temperature range, similar to ASP activated sludge process. Organic matter is chiefly converted to biogas, or all of the above statements are true. Answer is C. Organic matter is chiefly C. This those of you who have answered all of the above, aerobic process is similar to ASP. Okay, aerobic process, because what happened in ASP, we apply aeration, which is an aerobic process. This is not anaerobic process. So aeration we do. So when I would have written aerobic sludge digestion, then that is similar to ASP. So D is not correct. Two of you have answered D. It's incorrect. So what happens in anaerobic process? Organic matter is chiefly converted to biogas. Biogas like methane, methane we get, and it happens in mesophilic as well as thermophilic temperature range. Temperature range varies for anaerobic process. Okay, mesophilic as well as thermophilic. Let's move towards next question. This is question number 5 and I'll launch poll for it. These are the polls for question number 5. The dry solid content of a secondary sludge is typically higher than dry solids of primary, lower than dry solids of primary, or similar, or none of the above. What can be the answer? Try to answer this question. I'm talking about dry solids. It's not about the amount of sludge, it is about the mass of dry solids. Okay, while evaporating the water, whatever we get is dry solid. So answer is B, lower than the dry solid content of primary sludge. Why? Because as I've told you, in secondary we get more of biomass, and in primary we get some inorganic particles as well. Okay, that is why the overall dry content is less than, see, the solid content of secondary sludge is lower than uh, dry solid content of primary sludge, because secondary sludge is mostly biomass, means microorganisms, dead or living. They constitute less than the inorganic particle in percent weight. That is why this is happening. This is the question number 6 and I have already launched the poll for question number 6. In dissolved air flotation thickening, in short DAF thickening, minute air bubbles get attached to solid and causes the solid to separate from water in the upward direction. This happens because this is the container in which DAF is happening. We are providing air, so particle will rise with gas. So why they rise? It depends upon the specific gravity or volume of water. First of all, this you need to decide. It depending upon the specific gravity or the volume. Anything that floats above water has lower specific gravity than the water. So volume doesn't play a role here. Here specific gravity plays the role. So answer could be between these two. Yes, correct, 100%. It's correct. So what will be the answer of this question? Yes, all of you are correct. Answer is A. Anything that floats or rises will have lower specific gravity than the solvent itself. So this is the rule. That is why it rises, because gas all have lower specific gravity than water fraction. That is why they will rise. These solid particles will be attached in the gas and that's why they will rise. So this is how they will be separated from the water. Which of the following is not an advantage of sludge centrifugation? This is question number 7 and I have launched the poll for question number 7. Less space requirement, less order potential, primarily used for primary sludge. And which of the following is not an advantage? So all of the above is not an advantage. Why do we centrifuge sludge? Try to answer this question. No one is answering it. Yes. Yeah, that is there. Centrifugation or any thickening process we do for to separate wastewater from water. But why we use different types of centrifugation techniques, and why sometimes thickening technique used for one type of waste is not applicable to another? There are many questions that we need to answer. Okay, we'll see the answer. So answer is tree. See, there are two types of sludge. One is primary, second is secondary. The primary sludge mostly has organic matter, mostly, and secondary sludge has biomass, mostly. So let's talk about two thickening techniques. One is gravity separation, another is centrifugation. If we will do gravity separation for this secondary, what will happen? There will be more biomass. The microorganisms are already there. And what happens in gravity separation? Everything is settled down one above the another. So biomass, all these things are already there. So this may rise. It won't happen properly. That is why for secondary sludge we go for centrifugation. So gravity is easy, gravity separation is easy and cost effective. But for secondary, just because they have biomass, we have to go for centrifugation. So sludge centrifugation is primarily used for secondary sludge, not for primary sludge. Okay? See. However, it is commonly used for thickening waste activated sludge, means biological process, and primary sludge is normally not fed to centrifuge as it may contain abrasive material. Okay, because there are some inorganic particles as well, so while centrifugation they may harm the walls of the centrifuge. So gravity separation is easiest as well as cost effective, so one will go for gravity separation all the time. But what happens in secondary? Due to biomass it won't settle properly. That is why we go for centrifugation. This is how you can remember it. This is question number 8. Thank you, Amit. And these are the polls for question number 8. Which of the following sludge thickening methods has the highest energy consumption? Screw thickener, drum thickener, belt thickener, or centrifuge thickener? This is kind of memory based question. You have to read the passage, you have to remember it. So this you can answer. So answer is D, centrifuge thickener. So this is that I told you, there is no trick. You have to just remember this points. The centrifuge thickener has highest energy consumption compared to screw, drum, and belt thickeners. This is question number 9. Sludge digestion results in the, why do we go for sludge digestion? Reduction of total mass of solids, removal of pathogens, reduction of biological and chemical reactivity of the sludge, or all of the above? Yes, correct answer. Yes, all of you are correct. So answer is D. This is used for reduction of total mass of solids as well as pathogens and chemical reactivity of the sludge so that it can be handled in the further processes easily. Which of the following conditions are not suitable for anaerobic sludge digestion? Not suitable. We are doing anaerobic sludge digestion. So anaerobic sludge digestion means we are not using any oxygen. This thing is happening without oxygen in a closed reactor where there is no flow of gases. Answer is A, psychrophilic. So all of you are correct. So anaerobic sludge digestion can either be thermophilic or mesophilic. Never temperature psychrophilic. Temperature psychrophilic means almost 20 degrees Celsius. So this is quite cold. Anyway, very less microorganisms can work in this temperature range. That is why we put things in fridge so that the microorganisms can are like not able to react on those foods. That is why our food is lives longer in fridge than in open environment because the temperature is psychrophilic. But still, we have seen sometimes our food gets stale in fridges also because there are some microorganisms, very few, but there are that can act very rapidly in psychrophilic temperature ranges. That is why our food gets stale in fridge as well. Select the incorrect statement regarding sludge conditioning. Why do we do sludge conditioning? To improve dewatering characteristics, and ferric chloride, lime and alum are used for thermal conditioning. A thermal treatment process produces more readily dewaterable sludge than the chemical conditioning. What can be the answer? Yes. So the answer is B because we have to select what is incorrect statement. Why do we do sludge conditioning? We try to improve the dewatering characteristics. And how do we improve it? By using some thermal as well as chemical treatment. In thermal treatment, the produced sludge is easily dewaterable than the chemical conditioning, because in chemical conditioning there may be formation of some complexes that will hold water between those complexes, so water won't leach out. And we are talking about thermal conditioning. What why statement B is incorrect? Because we are talking about thermal conditioning but we are adding these chemicals. I hope you understood. Let's move towards next question. And this is the last question of the theory. Then we have some numericals. We'll solve that. Dewatering of sludge is done to reduce weight and volume of sludge, increase the calorific value, reduce the probability of leachate generation of sludge, or all of the above. This is very easy question. So this is the answer. All of you are correct. Answer is all of the above. Dewatering of sludge is done to reduce weight and volume. Yes. Increase the calorific value. How do we increase the calorific value? When we will remove the water, then what we will get, it can be easily burned. Water we cannot burn easily, right? So calorific value means the amount of energy produced like from the sludge. So the amount of energy produced will be more when the water is removed. And reduce the probability of leachate generation of sludge. If there is water, we will get leachate. What is leachate? It is just the water in which many chemical and other things are dissolved, and it leaches out of sludge, and that is very harmful. You must have heard about leachate generation in the solid waste management, like landfills and all. So now we will see numerical questions. So the question is, question number 13, 14, 15 is based on this numerical only. So I wish you will note down all this value. A thickened sludge received from secondary treatment with the total volume is 80 meter cube per day. We have total volume and total mass. This you should note somewhere. And we are digesting it in anaerobic digester. The sludge is 70% organic and 30% inorganic. Important point is it is 70% organic and 30% inorganic. 60% of the organic fraction is converted to liquid and gases end product after 30-day period. Looking at 30-day period, you should understand that always anaerobic process takes longer than aerobic process. That is very important thing. Why? Because I have already told you, when we have aerobic process, more biomass is generated. More the biomass, amount of food is limited. If there are more biomass, it will eat up the food from all everywhere, from all around. And in anaerobic system, what happens? Biomass is very less. Amount of food is same, but biomass is very less. That is why it will take more time for the particular treatment, particular degree of treatment. So that is why here we are using anaerobic digester, and the timing is of 30-day period. It's very huge. So the digester sludge has a solid content of 5% and must be stored up to 90-day period. I hope all of you have noted down. May I go to next slide? You can reply. Okay. The total mass remaining after digestion per kg is, you can try to answer this question. For these kinds of questions, when these questions will come in exam, you will put value. Okay. So we will have a particular range. If the value is between that particular range, then only the value will be correct. It's not like you are writing one single value and only that particular value is correct. We will have a range. If your value is falling between that range, all of that value falling between that range will be correct. This value is depending upon the mass. Total mass is, initial mass is 35,000. See properly, 70% is organic, 30% is inorganic. Okay. And digester sludge has solid content of 5%. These values will be used to solve this problem. Do you have any answer? I'll wait for a few seconds, then we'll see the answer. Okay. So as you can see, the correct value is this, but we have very good acceptable range. So if your value is falling between these range, everything will be correct. Total mass was 3500 kg per day. Yeah, 3500 kg per day. Organic fraction is 70, inorganic is 30. Inorganic fraction after digestion is 40%. Okay. So organic fraction of solid, because only organic fraction will be digested. That is why we are talking about organic fraction. 2450 kg per day. Organic fraction remaining after digestion, 40% is remaining, 980. Inorganic fraction of solid, this much. Total mass, see, nothing will happen to inorganic. Inorganic will remain as it is. Whatever inorganic portion is there, it will come around after in sludge. If anything is happening, that thing will happen only to organic fraction. That too, the organic fraction, some will form water and gas, they will go away. The leftover organic fraction will constitute sludge, and all of the inorganic fraction will be there in sludge. That is why this value will be there as it is, and only there are changes in these values. So total organic fraction was 2450, remaining after digestion 980. So that is how we are getting this value. Okay, you can see these questions properly after class. Then in case of any doubt, you can tell me in the next class or you can write in the forum. The digested sludge accumulation rate is now here we are talking about volume per day. Here we have calculated kg per day. Now we are talking about meter cube per day. So this you can answer. Little calculation is required. Total mass of solid was 2030 that we just calculated. Solid content is 5%. Specific gravity is 1.01. Specific gravity, sometimes it is given or sometimes you will just assume. For organic, specific gravity will be around this, and for inorganic it will be around 2.5. So we are dealing with organic particles here in anaerobic digestion. So we have written specific gravity of inorganic. Though okay, digested sludge volume V2 is, V2 will be, this is nothing, mass upon volume. All these calculations, this is very easy density kind of calculation. Density, specific gravity, this is mass, and this is the volume that we get. So this is the answer. You can look at this, and in case of any doubt you can ask. Then we'll move towards last question. Any value between 35 to 45 meter cube per day will be correct. Okay, we'll see the last question. The required digester volume is, this is the digested sludge accumulation rate. Okay, that we got 40.2 meter cube per day. Now we want to calculate the digested volume. That was for accumulation what? For 1 day. For how many days we are using, and all those calculation you have to do to find out this digester volume. Try to answer this. We'll see the solution. Time is 30 days. You have seen in the question. Accumulation sludge volume is 40.20. So just we have to multiply and we will get the answer. Yes, Amit, correct. So as you can see, your value is falling between the acceptable range. So all of the values are correct. This was the last question. Any doubt? You can ask your doubts now, or you can type your questions in the forum, and we'll address it in the next class. Okay. Shall we close the class? Okay. Okay, we'll close the class now. Thank you, everyone. We'll close the class now. I'll close the class for everyone. Okay. Bye bye. See you in the next class.